So the divisible sum pairs. Now this problem takes an array of integers, and a positive integer k. Determine the number of ij pairs where I is smaller than j, and the ith element in the array plus the jth element in the array is divisible by k. So say for example we have an array, 1, 2, 3, 4, 5, 6 are the numbers in this array, and k equals 5. This might be a bit confusing, so let's take it into the whiteboard. So hopefully it's a bit more clear on the whiteboard. Let's go into this. Determine the ij pairs where I is smaller than j, or I is less than j, and the ith term in the array and the jth term in the array added together is divisible by k. So let's see what this means. We have an example array here, 1, 2, 3, 4, 5, 6, and k is going to be 5. How do we first work out if I is smaller than j? Well, what are I and j, first of all? So what might have caught you off guard is that you're initially thinking I and j are the elements in the array, but they're not. Only array get I and array get j are going to be the elements in the array. I and j are just indexes themselves, and they're always going to start from 0 because in an array it always starts at 0. So your initial instantiation of I and j are going to be 0. So what you can see here is I have a nested loop, a for loop inside of a for loop. And essentially what that means is, for one iteration of this for loop, all of the iterations of this for loop will go through. So when I is 0, because that's the first index of an array, 0, when I is 0, j will also become 0. But then, because we're still within this for loop and not this for loop, j is going to go through every up to index 5, because there's 5 indexes, 0 to 5. It's going to go through all of them. So essentially, at any one instance, I will be an index of the list of the array, and j will be an index of the array. And what we're looking for is where j is bigger than I. So it would be the instance of the second time round in j's loop where I is 0 and j has gone up to 1. From there on, it's always going to be bigger. And what we need to do to be able to capture that information, essentially, is within this nested for loop, where it's going to keep going around, we're going to have some sort of logic, essentially, to say, is I smaller than j? Because if I is smaller than j, then that's the first part of the problem that we've validated. That's fine. Therefore, we can then incorporate the next part. If I is smaller than j, then move on to the next bit. So we're here. It's got a nested for loop. It's got to a point where we've worked out if I is smaller than j. So if we're at a point where I is equal to index 1 and j is equal to index 2 or 3, we know that I is smaller than j. But this is the part where we do the calculation. So what is our calculation that we're asking for? We're going to get the value at the ith index and get the value of the jth index of the array, and we're going to sum them together. And then we say, is it divisible by k? K in this case being 5. Many things can be divisible by k, or in this case 5. We've got 10, 20. So how do we work out if something is divisible by 5? You can use a terminology, modulo. When you use modulo, you ask, is there any remainder left over? So when you have this particular value, whatever it is, say it's 10, we say 10 modulo k, in this case 5, 10 modulo 5, and see what would be the output. The output would be 0, because there's no remainder. So what we essentially do here is we have this bit within the nested for loop, within our if statement, our conditional statement, that says if array.get, because this is Java we're going to be using, because it gets that value at that particular index, plus array.get j. What do? We use modulo. If that sum, modulo k, whatever k is equal to 0, because we're trying to work out, is it something that is with a remainder or without a remainder? So if it's 0, it means it hasn't got one. Then we know, essentially, that it's smaller than I and j, and the second one has been clarified. So we can have some sort of count here, add 1 to that count, and then we have one more on the count of how many satisfy our queries. I hope this makes a bit more sense. Maybe when I start the programming, it will make even more sense. Okay, now let's start coding. What do we want to write first? We want to write our for loop. We want a nested for loop. So we're going to start with I, instantiate at 0, because obviously the first index of array starts at 0. Then we want I to be smaller than n. What is n? It's the amount of indexes within our array. So that's already pre-calculated, and that's here. And then we're going to add 1 to I as we go around, because we want I to greaten as we loop around, loop through the array. Now I'm going to duplicate it here just to save time, and I'm going to change all of the i's to j's because it's doing the exact same thing. It's a nested loop. So I hope that makes sense in mind of what we just done in the whiteboard. Now what do we need? We need our if statement. If I is smaller than j, then it's good. If it is, perfect, it's great. But then what else do we need? We need if array.get, as we mentioned, I plus array.get j. That will give us our sum value. But if what in relation to that? Well, if that value modulo k, whatever k is equal to 0, count plus, as we mentioned. You might say, well, what's count? The count isn't here yet. Well, we just go right to the top. We instantiate count. Int count equals 0. Count's instantiate. But obviously, we want to return something here. We want to return count right at the end. Quite a simple piece of kit. Let's run that. Yeah, perfect. Congratulations. It's lovely, simple code, and it works first time, and you submit the code. All test cases pass. Beautiful. I hope you enjoyed the tutorial, and I hope it made sense. Thanks, and please like the video, subscribe to my channel,